Good morning, everybody, and welcome to Discovery Hall on the campus of Central Washington University, the home of the Geology Department. We're going inside today. The raindrops are starting to fall, and we join Susan Kaspari. Hope you enjoy this episode. Is it raining right now?
Not too bad, no.
Let's take a little walk. Let's take a little walk. We can handle a few drops. So you've had both undergrads and grad students kind of regularly, it seems like, right?
Yes.
Can you describe over the last decade the kind of work that they've been doing with you, using that lab in particular?
Sure. So,
Let's go this way.
Okay. Yeah, so there's two different projects, or two kind of different range of projects that the students are working with. So some of them have been working with ice cores.
Okay.
So some have either worked with ice cores that we've collected from other locations. Yeah. And then we've also collected on a couple of occasions ice cores from Washington State.
Okay.
And so some students have been able to be involved in the drilling of those and then coming back and doing all the processing and the analytical work.
Wow.
So yeah, that's been great. And then undergrads, the students that have been involved in the actual collection of the ice cores have been my graduate students, but the other work, looking at seasonal snowpack, a lot of undergrads have been involved in that. So we've been able to do that just right out here outside of Ellensburg. Did work up in the Table Mountain area. We've had students, often I'll take them up to Mount Rainier. That's a really easily accessible place for us to be able to go.
Ooh, baby.
And so we've had, so there have been a few different programs that have been able to support students to have summer-long research opportunities. So working in the lab for a couple of months, that's been really great.
So you were doing some of that before we had this new building, and you're dealing with freezers in the hallway. And
yeah, no, that was a mess.
What can you describe? That was kind of like a...
Yeah, that was a mess. We did what we could, and we got it done. But yeah, at that point in time, I had chest freezers.
Yeah.
And then we would, there was one ice core that we processed where we would pull it out of the chest freezer, and we'd cut it as fast as we could on the bandsaw and then get it back into the freezer.
Oh my God.
And yeah, that was, we ended up with some rust problems on that one. But so those early days were far from ideal. And then, but with the new building, we were able to design those to specification, and now, it's a state-of-the-art facility. And
well, looking forward to seeing it.
Yeah.
So did you have a lab that was kind of a model for what you wanted here?
Yes, I've worked during graduate school, I worked in an ice core facility at the University of Maine, and then I worked in Switzerland at one during my postdoc, and I've also been involved in processing ice cores at the National Ice Core Laboratory in Denver. So I've been able to see a range of what the facilities look like, and knew well what my needs were for a freezer space as well as the analytical capabilities. And so we were lucky that they were allowing us to design our labs pretty specifically for what our needs were. So it's not a huge facility, but it's very nice and on par with some of these other labs that I've worked in.
So you started what year? Remind me.
2009.
I thought so. And were we sure we were getting a new building at that point?
When I interviewed, Wendy was talking about the new building. So yes, but it was a long time in the works, because I came in 2009 and we moved into the building in 2016.
Yeah.
So yeah.
Okay. Well, so you've got it all up and running, and the thing that's impressive to me is that, especially for our undergrads, it feels like they just get started in our program, and before I know it, they're like, yeah, I just met Susan and I'm going to do a project with her. So are you taking students with you must be, you're taking students with zero background in some of that.
The nice thing about what my work is that it is, it falls in the realm of geosciences for sure, but it's not that they need, it's a pretty specific branch of science that I can train them up in. So it's not that they need to have already taken mineralogy in order to be able to do the work. So it's just a very specific set of skills. So basically if they're interested, then I can work with them. So for some of the undergraduate programs, they were bringing in students, some of the students that were in their first 1 or 2 years
Yeah.
were able to participate.
Yeah.
We, in our department, we're lucky to have more than a half female faculty right now, which has been really great for setting role models of the diversity that we can have in our department. But at this point in time, we're Central is I really value CWU for, where are we going, Nick? I really value CWU for the students that we serve. So we're serving a lot of students that are first generation students or coming from groups that are less represented. And so I think in our department though, we have, we're making a lot of progress in having our department represent the demographic of the overall CWU population, but we're still not there yet. So I think the faculty is really dedicated to, increasing the diversity of our faculty, increasing the diversity of our students, and so we're improving there. But
we are.
Yeah. So and we're learning a lot as we go about it. So one of the grants that Carrie and I wrote was a Keck Undergraduate Research grant, and that we've got these absolutely phenomenal facilities in here, and so that grant was intended to be able to better incorporate the instrumentation into our classes so that our undergraduate students are being able to interact, either running samples directly on those instruments themselves or working with data that came from them. And then the other big part of that was providing research opportunities for students. And so, we're looking for students that are interested and passionate to get involved in the research, but it was also a priority that to include to make sure that there was a diverse representation of students that were participating in that research.
Excellent. You've been a leader in that, and oh, good. We are in the right place. I thought it was said physics down there. I'm starting to get worried. Like, are we in the right building? Yeah, we share it. Well, this is the huffing and puffing part of the program. I mean, you must get a good workout coming up here on the third floor every day.
That's a good thing. In 10 years, it'll hopefully still be okay.
So you're up on the third floor with many of our faculty, and this is open to the public, people can come up here and wander and look at these posters and everything else. Did it make sense to have your ice core lab up here on the third floor for like venting reasons or other reasons I have no idea about?
You know what, I think it did, but I don't remember what they are now. Yeah, so it's nice though. So Erliana's working in there right now.
Oh, hey, let's crash the party. Okay, hi.
Yeah, so Erliana was one of 3 students that worked in the field and in the lab last summer. Okay. Yeah, I don't know if you want to see in there, but
sure.
Maybe at the end. I don't have my keys now.
Okay.
But you can grab them back.
Okay.
But maybe we could pop in there quickly after we go in. But if you want, I could pull up the ice core drill and just show that quickly.
That'd be wonderful.
Okay. Do you have your keys?
Yeah.
Okay, you can get in there.
Okay. Well, she looks busy, so she's not waiting for us. What's Wasser? Is that you?
That is the Keck Undergraduate. So that was the Water, Air, Soil, Snow Environmental Research Laboratory.
Okay.
That's what it got named.
Uh-huh.
This will take me just a second to pull this out.
That's good. That's good. Oh, wow. State-of-the-art couch here. Look at this.
Yeah, that's left over. I think Melanie Swick.
Oh, God, Melanie.
I brought that.
So while Susan is kind of getting a couple things open, I just want you all to know that I'm introducing you to this building, and if it's school hours, this building's open, and this is this is a place for you to enjoy all this work that's been posted here. I always feel it's always struck me that we're posting all these incredible studies and everything else, and nobody comes to the building to look at it. It's just, it just doesn't feel right. So this is just an attempt. I'm going to turn more light on if you don't mind.
Yeah, so you can bring those up. Yeah, there we go.
Yeah.
Yeah, so Carrie and I share this space. So we store a lot of our stuff in here, and then we're able to have meetings with students. But this, I'll just show you quickly. This is an ice core drill then that we use to retrieve little ice cores. So more just if we want to get a shorter ice core.
Yeah.
So this total system weighs about 70 pounds. So we're able to backpack it in. So we've backpacked this in. We've taken it in and drilled on Snow Dome over on Mount Olympus on the Olympic Peninsula, and up in the North Cascades. But yeah, so this is cool. It's got a motor in there, and then we attach, there's a couple different barrels, and I've got at the bottom of the barrels, I can just show you this real quickly, but there's a cutter. Woo, I'll get that out of there. Yeah, so there's cutters, so this thing spins, and we'll collect about 70 centimeters of ice, and then we'll pull it out of the hole, and these little things hold the ice core, keep it from dropping out of the barrel, and we're able to get that ice, easier said than done. We get that ice back to the lab frozen, which sometimes involves helicopters to be able to do that.
Sure. I'm surprised and impressed at how tidy this is. Like
yeah, so there's two barrels. This is the scale of what an individual scientist would own.
Yeah.
So I can only drill about 20 meters or 60 feet with this drill. So as soon as you start to get into the bigger drilling projects, those then will be owned at the national or the international level, and then you start, you'll apply right into your grant that you need this bigger drill. But this is nice because we can just take this in ourselves and go drill something on our local glaciers, which we have a lot of, although they're melting quickly.
Yeah, that's what I hear. Okay, so Erliana's been out. Yeah, she's been out in the field with you then with both snow and ice. That's the confusion I have. I never quite know who's doing work on ice, who's doing work on snow, and are you going back and forth with both of those mediums?
Yeah, I go back and forth with both. The students from last summer, we'll have to ask her to let us in. Yay, she's coming.
Oh, that's nice. That's a good sign, Susan. She's not
student.
pissed.
You can tell we treat her well. Thanks, Erliana.
Erliana, thank you for spending time with us this morning. Yeah, let's see, the mic thing.
Do you want me to just, I could show you here
Let's
quickly,
do it.
and then I can I'll hand over to Erliana.
Good, yep, that works.
Okay, so 2 more minutes with me, and then we'll let
At
Erliana.
least, let's roll this. You got a few more minutes?
Yeah. I'm
okay, all right.
Okay, come with me in here. I'm going to show you just a couple different pieces of ice.
Woo!
Yeah, so we should have you film the temperature control.
Right.
So it's negative, we keep it at negative 18 degrees Celsius, or about 17, or about 0 degrees Fahrenheit. And so what you have in here, we've got ice stored in here from around the world. So when we bring it back from that drill, it's in big cylinders, and then we have to cut it up to get it into pieces that we can then analyze. So this is the bandsaw table that we use for that. But I'll just show you, just quickly a couple different pieces of ice. I'm going to turn off the light. Is that okay for you?
Yep, you bet.
So this is a piece of it's fern. It's snow that's densifying and turning into ice. But this is core from Antarctica. So I don't know if you can pick it up, but one thing that's cool is you can actually visually see things in the core here. Yeah. So there's a little melt layer here.
Yep.
Okay. So that tells us something about seasonality. What do you think? Would that be winter or summer, where we see this clear little layer that comes from melt?
Summer.
Yeah.
Thank you for the hint, by the way. I panicked there for just a second, Susan.
Yeah, so that's an example of some ice that we have from Antarctica. This is one from the North Cascades, so South Cascade Glacier and the North Cascades. And this is unusual here in that you can visually actually see a band. And that one there is related to wildfire, where there's been deposition of black carbon from wildfire.
Holy cow.
Yeah. So I'll let you guys hop out. I'll throw that away.
Woo! I can't believe this is the same building that I work in every day. I feel like I'm on a different...
Well, next time you're hot, you'll know where to come.
How about one more thing about just an overview of your design?
Sure.
And then we'll go to Erliana. We're still thinking about potential students coming here and like finding themselves suddenly in this space.
Yeah, so this is the space where we can do further work processing the ice cores, and then where we can do analytical work.
Yeah.
So this right here is a freezer where we could put an ice core in here, and that little thing down there is a melt head. So for ice cores that are really clean, like those Antarctic ones, this is how we process them.
Yeah.
So this is where we would melt the ice and get them into samples and make measurements. And then what Erliana is going to be able to tell you about is some of what we're doing with the dirty snow. So the idea behind the dirty snow work is that, you know, climate's warming up and warmer temperatures leads to snow melt, but that's only part of the story. Another really important part of the story is that there's things getting deposited on the snow that cause the snow to melt more rapidly.
Yeah.
So my students and I are studying black carbon, dust, and organics, all of which can lead to that. And Erliana's got experience with studying all of that, and you could take it from there. I guess all I'll say is in terms of the layout, so this whole suite over here is designed really for us to be able to measure with black carbon, so that it allows us to have all the instruments. And there's other instruments that I pull out when I need to calibrate this one. But this is the instrument that we use for measuring black carbon, and this allows us to go from a liquid sample all the way to where we can actually measure it. And then over here we just have a bunch of different balances, things that allow us to filter that sort of thing.
So the amount, you're doing the training personally, I'm guessing, with your students.
Yes.
And it takes a while to ramp somebody up?
Yes, I mean, especially with Erliana, we were going to work together for 2 months, and so Erliana's trained on a lot of the instrumentation.
Yeah.
I mean, she was working full time and with 2 other students, so Erliana knows how to run everything in here, including also is trained on how to use the microscope that allows us to go down at particle scale to look at some of this dirty stuff in the snow.
Wow.
But this quarter right now, I have a few students that are working just a few hours a week, and they're doing more, you know, filtering, like these. They might. I don't know if they have anything in here right now.
Oh, I noticed new filters.
Did you? Yeah. So they're doing. I've got 3 students right now who are looking. These are different filters where we're looking at deposition of material in post-wildfire environments.
Oh, I see.
And so this is what some of the other undergrad students are doing right now. But because they only have small chunks of time, they're not working with some of the more sophisticated analytical instruments like Erliana did.
This is great. One more thing from you. So if somebody comes here
Yes.
as an undergrad to study geology, are they going to have you in class? What classes are you teaching?
Yeah, so I'm teaching Geology 201, our climate and water class that I teach with Carrie, and
Okay.
so that's kind of our intro, one of our intro series into the major.
Yeah.
And then I teach our oceans, atmosphere, and climate interactions class, which is a 300 level course. And so those are kind of getting out of for just solely in the lithosphere, but taking us out to kind of studying the overall Earth system and really understanding what's happening in the story of the atmosphere, the ocean, and our climate.
And who ends up in this room? Are you reaching out? Is the student begging to come and do something with
actually,
you?
they all 3 students that worked with me last year independently approached me after that class asking for research opportunities,
Yeah.
and that worked out great. And then actually all 3 that are working in the lab this quarter all individually reached out to me as well. But if I've got research that needs to be done, then I go asking. But otherwise, the students, you know, some students absolutely love, you know, looking at the rocks and the minerals, and you know, those ones go to other people in department, and the ones that find the climate side of things really interesting, you know, the climate water, they come talk to Carrie and me. So.
Well, let's talk to somebody who's done the work as a student here. So thank you. Oh yeah, let's just try this. We'll keep this blue button going. Susan, that was wonderful. Thank you. You're just such a natural with this.
Trying to follow your lead.
Oh.
I went to Oscar Smith High School, which is in Chesapeake, Virginia. So yeah, I grew up over there,
Yeah.
and when I graduated, we moved over here to Washington.
Okay.
And all throughout high school, I had to think about what we had to do
Yeah.
for college, and I was like, well, I like rocks, so I'll go into geology. At first, I thought it was just rocks, but then when I came here to Central, I came to Central because I heard the geology program was really good.
You did.
And it was close to home as well.
Mhm.
So when I got here, I learned that it was more than just rocks. And yeah, I already knew from the start that I wanted to do geology.
Nice.
I was taking oceans and atmospheres, and I was enjoying the class. And then just like one day after class, I was like, are there any research opportunities? And she's like, yeah, you've been doing well in my class, so I think it'd be nice to work with you.
Well, just for the
Just
record,
go from there.
you're doing well in all your classes, and you're doing more research than just with Susan, right?
Yeah. Yes.
I mean, come on now. So you've got an engine there. I'm impressed. Can you describe the project or projects that you've done here with Susan, and are you done with the project?
So the project we were working on, it was over the summer, and we basically went to Mount Rainier with 2 other students as well, and we collected some snow samples to see the different variabilities in the particles that show up there, like the organics or like dust, carbon, that sort of stuff. And then we would come here and
Show us what. So let's pretend we're bringing a sample in here. You can maybe help us get a sense of the process.
So we would grab samples from the freezer and we would like melt them down, and as we were waiting for them to melt, we would put them in these jars.
Yep.
And we would start making standards with these jars from this like concentrated carbon, and dilute it and make a bunch of different standards of different concentrations and run them through these machines to make sure the machines are properly calibrated.
Yeah.
And then eventually by that time the samples are melted down, and then we would take the samples and dilute those and then run them through to get the concentration of carbon. And
go ahead, please.
yeah, and also like we would only use a small bit of the sample, and so with the rest of the snow samples we would run them through filters, and we would also put them in crucibles and like grind them up later on
I see.
to run them through other instruments.
Mm-hmm.
Here's one of your guys's.
So Susan, was this a improvisation once you got here to start working with the snow, the dirty snow, or that was also part of the plan?
Well, my background was in studying ice cores,
Yeah.
and so I'd worked with lots of different chemistry. But then during my postdoc, I became an expert in black carbon. So then I was studying black carbon from ice cores. But then a lot of the story with black carbon, which is from incomplete combustion of biofuels or fossil fuels, is also just how it's getting deposited on our seasonal snowpack. And so I was really working with that, and then over the years it became clear that to know how important the black carbon is, you got to know how much dust and organics are, and so we were basically investigating that at Mount Rainier.
Got it.
Yeah. So anyways, there's some of the dirty stuff, and you could show some of your filters if you want, Erliana.
I was trying to look for like the cool red filters, but then I saw that they got green over time. So yeah, these are the bigger filters.
Okay.
Kind of cool.
You approached Chris Mattinson about working with him?
Well, actually, it was me and Alexis, another student who's done research with Chris. We actually we had him for mineralogy, and we were asking him a question about homework or maybe a lab or something. And eventually we got to talking about like research opportunities, and he was like, oh, I have this project that I think you guys would really enjoy working on. How about you guys try this? And we were like, okay, I mean, might as well.
So what was that? What was that project?
So basically there's this zircon separation table, and it's just like this large table that vibrates, and it has grooves. So you crush up a rock sample and run it through the machine, and there's also some water that comes out with it, and basically it vibrates and it separates the zircons, because zircons are much more dense, and you want zircons so you can better find the date of rocks.
Okay.
And then I started doing research. Was it spring or technically summer?
Well, we started to do some stuff, spring of last year. Yeah, so that
Spring
was
of last
2020.
year.
Okay.
Yeah, so just my junior year, basically.
Yeah, but it was obvious to you at some point in the program that this was possible for you. That this was not just for graduate students. It wasn't for somebody who had all this advanced training.
Credentials. Yeah, no,
Right.
like anyone could do this.
Yes.
As long as you like reach out to your professors.
Right.
They make it pretty easy. It's
Yeah,
great.
and Alexis, who Erliana worked with and who was involved in my lab, 2 summers before you were. So Alexis had come to me as a freshman through the Science Talent Expansion Program, and then she ended up working as Keckwasser, but much earlier on. So she was more a sophomore when she was doing a lot of that research. And they're both graduating now.
Yeah.
So you'll be looking for new students. If they come here,
I
they might.
sure will. I'm excited to train more and get them in the field and get them in the lab.
Wonderful. Thank you both for your time.
Thanks,
Loved it.
Nick.
Thank you.
Good morning, Trent.
We're just talking about jobs.